Welcome back. So in last part we discussed the radius of the electron in nth orbit, and then we discussed the energy of the electron in nth orbit. Also evaluated the form of the Rydberg constant, right? R. You have to remember this thing. We have then there are three things we have to remember. First one is our Bohr orbit. Let me write it clearly because lots of numerical question can be asked from using these three values. Actually, this is called Bohr radius or first Bohr radius, but in general it is used as Bohr radius, which is 0.53 Armstrong E1 minus 13.6 electron volt. Actually A naught is also actually R1. Okay, so that's why it's important. E1 and another one is R, the Rydberg constant. And the value is so these three things are important. It's good to remember. Okay, but one thing if you notice, why we have done this? This is also constant, so we can also deal with this m square e to the power 4 this part, but why we have multiplied by CH, then we divided with CH to build a new type of constant. This is Rydberg constant. Why? This is important. Okay, let me give some idea. What was E? We know E is actually h nu, right? From this is a Planck's equation, okay, and nu is the frequency, so we can write it c by lambda. So it is actually hc by lambda, correct? Hc by lambda. So now we can write it 1 by lambda into hc. What is lambda? Lambda is wavelength. So 1 by lambda is actually wave number. It should be, because if nu is the frequency means number of total number of full wave in 1 second. That is the frequency, right? What was the frequency? This is the case. Let's say this is for 1 second. So in 1 second there are 1, 2, 3 full waves. So nu is the number of full waves passing in 1 second or generated in 1 second. That is the frequency. So 1 by nu, that should be the time period t. That means for one full wave this t time is required to be generated. That's the case. Here also, if this is the lambda from here to here, this is the lambda. Lambda is the wavelength, length of one wave, then 1 by lambda should be the number of wave present in one unit. In lambda length there is only one wave, right? One full wave. So in unit length there must be 1 by lambda wave. So that is the wave number of wave present in unit length. So that's why it's called the wave number. So this denoted by nu bar. So this is, you can write nu bar ch. So E is nu bar ch. Okay. So E is nu bar ch. So what was the unit? E has the unit joule. Okay. Nu bar has the unit meter inverse or centimeter inverse, that means length inverse, because it is 1 by lambda and lambda is the wavelength. Actually what happens, or most centimeter inverse or anything we can convert, that depends, the unit depends on the C. If we put C in meter, that means meter per second, then it will be meter inverse. We can check. If it is, let's say C is in meter second inverse, H is joule second. So nu bar should be joule divided by meter second inverse joule second. So meter is, so it's meter inverse. If we consider that centimeter, then it will be centimeter. So the unit of nu per is totally determined by the which unit we are considering for the speed of light, whether it is meter in meter per second inverse, then is 3 into 10 to the power 8 meter per second inverse, or 3 into 10 to the power 10 centimeter per second. That is the case. So the unit may be meter inverse or centimeter inverse. So now for any term, so there was, right, E1 was there. If we remember, E1 was identified in this form, m e to the power 4 something, let us say x was the value of E, right. Now if we do the thing Ch by Ch, then what will happen, this is x by Ch will be the corresponding wave number of the energy, right, that is the case. So this energy and this wave number are related by Ch. So this nu bar is called the corresponding wave number of the energy E. So that is why we are, if we multiply it and divide it by E, then this part is the wave number. So this part will be the wave number. So that is why the unit of the R is meter inverse. If we remember, it is the unit of wave number. So in experiment, we can deal with the energy, deal with the joule, no issue with that, but the values, numerical values are so absurd in the unit of joule. So if we convert in terms of wave number, that means meter inverse or centimeter inverse, then it will be very easy to deal with. Actually experimental results are very it will be very easy to deal with the experimental result in the centimeter or the meter inverse unit, that means in the wave number. That is why it was multiplied by Ch and divided by Ch, and R is the wave number. Okay. So any energy we can convert it into a wave number. This is, so wave number is also, that is why actually represent the energy, though it is the wave number, but it's actually give the feelings of the energy. How just we have to multiply it with the Hc, which is a universal constant. If we multiply nu bar with a Hc, then we can convert the nu bar into the energy. So we can use the nu bar the wave number instead of energy. This is also actually way of representation of the energy. And in spectroscopy, in the because it's we have to deal with the atomic spectra, that is essentially a part of spectroscopy. So in spectroscopy we generally use the wave number part, we don't deal with the joule part. The centimeter is the actually centimeter inverse is widely used, very important unit in spectroscopy. We deal with the energy, that means this energy level energy is the 1 centimeter inverse. The energy is 1 centimeter inverse, though it's physically incorrect, but we have to understand the feelings, because this 1 centimeter inverse is actually the wave number of that energy level, corresponding wave number of that energy level, but we use that equivalently, that energy and the wave number. So we should not be confused with that. Nu bar is wave number, but actually it's represent a certain energy level, specific energy level. That's why it's also represent the energy. That's why in spectroscopy in general the unit of the energy used as centimeter inverse. That's actually the unit of the wave number. That was the reason here we have multiplied with Ch and divided with Ch. Okay. So let's proceed. These things are good to know actually. Okay. So what we have discovered, that En is proportional to these things, right. So for k we can write it Ek will be proportional to 1 by 1 square. For L means n equals to 2, right, K, L, M, N, O, these are this L. So for L it's proportional to 1 by 4. Em it's proportional to 1 by 9. En it's proportional to 1 by 16. So you can write it El is due, Em is due, Ek is there, Ek, El, Em, En, is equals to 1 is to 1 by 4 is to 1 by 9 is to 1 by 16. So, you can see that the energy of the second orbit, Lth orbit, is 4 that means 4 times less than the first orbit, the Ek, and again the third one is 9 times less than the first orbit. So, it goes on. So, you can see the energy are decreasing, actually increasing because that is a minus sign. Okay, this is actually the numerical value, means for E1 it was minus 13.6 electron volt. E2 will be, because E1 is to E2, we know this, E1 is proportional to 1 by 1 square, E2 should be proportional to 1 by 4. So, E1 is to E2 should be 1 is to 1 by 4. So, we can write it U1 by E2 equals to 4. So, U1 equals to 4 times E2, right. So, it is actually then E2 is U1 by 4, U1 by 4. So, U1 is minus 13.6. So, it should be 13.6 divided by 4 EV. So, what is the value? Minus 13.6 by 4 is actually minus 3.4 EV. So, you can see that this is actually greater than E1, 4 times greater due to the minus sign, but if we consider the numerical value only, the magnitude, then it is 4 times this is followed. Okay. So, now we have to identify the general form. It is easy because En was 4 pi epsilon naught E square by 2 A naught n square. So, we can write it E1 into 1 by n square, because this part is E1. So, we can write it. So, the form is En equals to minus 13.6 divided by n square, very important formula. For E1 we know electron volt. If anyone asked in joule, then we have to convert. 1 electron volt is 1.6 into 10 to the power minus 19 joule. So, in that way we have to convert. So, this is the form of En. Okay. So, from here we can easily evaluate E2, E3, E4 and so on. I am not doing the thing, just we can write it. For E2 we have write it, that is minus 5.4 3.4 electron volt. For E3 it is 1.51 electron volt. For E4 it is something. What we can see here, that the gap between E1 and E2 energy level, the value of energy, the actual gap, the orbiter or the radius of orbit is increasing, right. We have seen it. That is increasing, it goes far away, but in energy the energies are getting closer, the value of energies are getting closer if we increase the energies. So, we can also find it. This is the form of En, E1 by n square, E1 is constant. So, daily should be this daily in between n plus 1 and n, okay, in general n plus 1 and n, then it is this. So, this is minus 13.6 divided by this, and this should be plus 13.6 n square. So, if we take minus 13.6 common, always electron volt, then it is this should be the result, right, and it should be, because then this is the nth level, this is the n plus 1th level. As I discussed, if we increase the n, the energy should increase. So, En plus 1 should be greater than En. So, this value should be positive, right. as I mentioned earlier. Here we discussed na these things. If n increases, 1 by n square decreases, that means En will increase because there is a minus sign. Okay. So that's why it's positive. So now if n is very high, then what will happen? If n increases rapidly, then we can replace it like, then n and n plus 1 equivalent to each other. If we do it, then it will be 2n divided by 1 is negligible, then it will be n square, again n square, that means n to the power 4 something will come. Okay, we will not get into that, but this is the case. From here also we can have some direct problems, but that is the case that if n tends to infinity, then only E infinity will be 0, because this is the form. If n tends to infinity, then the energy will be 0. Energy is 0 means in that orbit, if n tends to infinity, then Rn is also infinity, because Rn is a naught n square. So the infinite orbit have energy, will have the energy 0 energy, and that is the radius is also infinite. This essentially means that the electron is in that case a free electron, that is already free from the field of nucleus, that is out from the atom. So if we draw the energy levels quickly, then we can see if this is the first energy, that is minus 13.6, then next this is 0, this is 0, let us say this is 0, this is negative axis, this is let us say negative axis. Okay. So this is minus 13.6, then next will be minus 3.4, then that will be minus 1.51, then minus 0.85, and if n increases, then it will be very closest to each other. So we can, this is ground state, these are the high. So we can see that the gap are decreasing if n is increasing. From here also we can see if f increases, this gap will also increases, right. So this is the case, we will discuss from here in next part. Let me stop here in this class, we will elaborate this part actually. In next class we will discuss the speed of the electron in nth orbit, and also we will discuss the atomic spectra surely, and the Paschen line, Balmer series, this series also we will discuss in the next class in details. Let me stop here in this part. From here also this we will discuss this diagram in details as well in next part. In next part we will continue from here. So for this part, let me stop here. Thank you for your attention. Okay, thank you.